Chapter 1, Section 4 is about properties of those real numbers that we talked about in Chapter 1, Section 3. By the end of today's lesson, you should be able to identify and apply the properties when simplifying an expression. Okay, we're going to start with our vocab. This section is actually just a lot of vocab, and then practice using that vocab. First, we have equivalent expressions. Those have the same value for all values of the variables. Okay, so that means we'll have two expressions, and no matter what you put in there for x, they will both still be equal. Okay, we're going to start with the commutative property of addition and multiplication. This one I like to think of, commutative sounds a little bit like commuting, which means driving back and forth from somewhere. And so for addition and multiplication, if you turn them backwards and forwards, they still work the same. Okay, so for example, if my A, say A was 2, B is 3, it doesn't matter. 2 plus 3 is 5, 3 plus 2 is 5. Works for both addition and multiplication. Next property is the associative property of addition and multiplication. Okay, associative, I like to think of associating. The people that you associate with are like your groups of friends. So associative has grouping symbols. Okay, and it only works for addition and multiplication, but what it means is it doesn't matter which two numbers are in the grouping symbols. It will work either way. So again, they have the numbers here. They have A being 23, B being 9, and C being 4. Grouping symbols tell you what you have to do first, but in this case it won't change your answer. So first they have A and B in parentheses. 23 plus 9 is 32, plus another 4 is 36. Okay, then on this side of the equal sign, 9 plus 4 is 13, plus 23, still 36. Works for both adding and multiplying. That's the associative property. You change who are associated together, which numbers. The identity properties of addition and multiplication. Your identity is who you are. So we're trying to keep the number the same, keep its identity. So if you're working with addition and you have a number, the only way to keep it the same is by adding 0. If you're working with multiplication and you're trying to keep the number the same, the only way to do that is by multiplying by 1. The 0 property of multiplication just tells you that the fact of any number times 0 is 0. That's your key word right here. Multiplication property of -1 tells you that any number times -1 is just its opposite. So 5 times -1 is going to be -5. -5 times -1 is going to be +5. So like I said, anything times -1 is just going to be its opposite. Okay, they want you to practice that just by listing which property they're showing in each one of these. So if I said 31 times 0 equals 0, and we look back at some of our rules here, this one right here, the 0 property of multiplication, tells me that anything times 0 is 0, so that's what this one is illustrating. The 0 property of multiplication. It's okay to abbreviate so it doesn't get too long. Okay, on B, change the color so you can see what I'm doing. On B, we have x plus 3 in parentheses plus 6. And on the other side of the equal sign, we still have x plus 3 plus 6, but this time we have a different set of numbers grouped. We have 3 and 6 in parentheses instead of x and 3. But it doesn't change our answer because it's all addition anyway. So if we scroll back, I don't see it there. It looks like this one, associative property, and this one was addition. So we're going to call it the associative property of addition. Okay, letter C says 5x plus 0 still equals 5x. So it looks like our number didn't change even though we added to it. Looking back, that appears to be the identity property of addition. Perfect. Now this is good practice for you. I won't do it with you, and I will only check it if you need me to, but it says create a problem that illustrates the following. So if you can create a problem that shows commutative property, for example, a plus b equals b plus a, or the identity property of multiplication, or the multiplication property of -1, the more you can write them yourself, the better understanding you have of these. So that would be a good practice right here if you want to pause and give that a try. Okay, word problems. A movie ticket costs $7.75. A drink costs $2.40. Popcorn costs $1.25. What is the total cost for a ticket, a drink, and popcorn? And they really want you to use mental math. So don't use a calculator, don't even write it down. See if you can do this in your head. Okay, what were some of your strategies? For me, I saw that 75 cents and 25 cents add up to another $1. So I took the $7 plus $1 and then one more with these, and that gave me $9, and then I added my $2.40. Sometimes it's easiest if we can find combinations that add up to more whole numbers. Gave me 9, and then I added another $2.40. This is what I did in my head. So I got $11.40 to buy a ticket, a drink, and a popcorn. If you have a different strategy, feel free to let me know. I'd love to hear it. Okay, another mental math. This time a movie ticket costs $6.75. A drink costs $1.90, and popcorn is $2.25. What's the total cost for one of each? Okay, I'm going to use the same strategy. I'm going to take this 25 cents and this 75 cents to make another $1, which means I'm left with $6 here, $2 here, giving me another $9, and then I'm going to add on $1.90. And I'm going to find out that for all of those things, it's going to cost me $10.90. All right, they want us to simplify the expression, which means to write an equivalent expression. If there's any variables, you won't get a numerical answer. You won't be able to finish it because they're not going to tell us what those variables stand for. Okay, so in the first one, I should be able to multiply 2.1 times 4.5 and then leave the variable. And that's going to give me 9.45x. Since I don't know what x is or what it's worth, that's as far as I can go. Okay, in letter B, I can only combine like terms. These can't actually get added together, but because it's all adding, I can combine the 6 and the 3. So I will have 9, and then I still have this 4h. And that's as far as I can go because I don't have any like terms left to combine. On letter C, if you remember from 7th grade, we can separate these into like terms. Okay, the 8 and the 12 can be simplified. If I divide those by 4, I get a 2 on the top and a 3 on the bottom. These two m's cancel each other out, so I won't have any m's in my answer. And then I still have this n on the bottom. And that is as far as I can go. Okay. If you want to try these, this would be a good place to pause right now and see what you can do on your own, and then come back and go through this slide with me. Okay, these first two are multiplying 4 times 8n. If I have 4 groups of 8n's, how many will I have? Well, 8 times 4 is 32 n's, so that's my final answer there. Letter B, my only like terms are the 3 and the 7. So I'll have a 10, and then I still have that 5b that I have to account for. So that's my final answer for that one. And on letter C, I'm going to separate like terms again. 8 divided by 2 gives me a 4. My x's cancel each other out, and then I'm left with a y. All right, if you have any questions on this lesson, please make sure to email me contact me somehow. But your assignment for this lesson is on page 26, 7 through 19 all, 20 through 30 just the evens, then number 36